Okay, so, interesting developments in game programming. Actually, before I mention that, in case you don't have it written down, today is the computer science get together, daily flippy thingy. So it's like at 11:30. 11:30 down the hall, free food, pizza and crap like that, and good prizes. I want to say like what are the prizes this year? An Apple Watch is one of them. What are the other good ones? There's two or three, the top tier ones. Might have been an iPad in there, probably some kind of good printer, a good monitor, maybe a big hard drive, something like that. Yeah, so that's today at 11:30 until like 12:45 or so, something like that. So game development news is kind of interesting. So the department has been doing a lot of stuff with virtual reality, and one of the limiting factors with VR up to this point, I mean, I think anybody who uses VR is typically relatively impressed with what it can do and things like that, as long as they have a good setup and things like that. But the point of entry for VR right now is quite high, right? So even though the price of the equipment has come down, the Oculus Rift you can get now for $400, and the Vive you can get for $600, and it used to be, really $800 or $900 for one and $700 for the other, and a lot more expensive. But just paying that for you're not done. You have to have a computer that's good enough to drive it, and usually that's going to require a purchase of at least a new graphics card. So you probably got another $400 to spend before you can actually drive the thing reasonably. So it's expensive. Point of entry is expensive into these things. Well, now on the flip side is we've had this idea of mobile VR for a while. Started with kind of Google Cardboard, where you take your smartphone, you plop it into this this device that effectively holds it right by your eyes. It has lenses in it that make it VR, make it become VR. And up to this point, that has been up to maybe, let's say, a year ago or a year and a half ago, something like that, that was pretty primitive. It wasn't really a great way of getting good content, specifically because the early Google Cardboard things were, it was called Google Cardboard because they were made of cardboard. You folded it and had sticky stuff and, made your goggles, and they weren't that comfortable. So, it was cool enough to put on for 5 minutes. And, then you had some companies come out, Oculus makes a thing for the Samsung devices called Gear VR. And but you can only use that if you have one of the newer, nicer Samsung Galaxy phones. Then Google makes a thing called Google Daydream, which only works with the Pixel and like a couple of other devices. So you have, as long as you use those phones, you can use, let's call it the better quality mobile VR stuff that's actually comfortable and has a, kind of a VR based operating system that you can use to select what game you want to play and things like that, or what video you want to watch. As opposed to Google Cardboard, where you have your phone out, you pick the application, you launch it, then you plop it into the device, shut it, put it on, and as long as you're going to use that application for a while, you're okay. But really interacting with what's happening on the screen is not something that is usable on Google Cardboard. They have a mechanism for it, but it's not very good. There's like this little magnet thing that you push here that simulates tapping buttons on the screen. So it's not that great. But in any case, as long as you already are carrying around a smartphone, so obviously these guys are expensive, but if you already had one and then you can turn it into a VR thing, great. If you had the Google phone, same thing, great. The actual cost of the VR headsets isn't too prohibitive. The Google Daydream is quite inexpensive, actually. I think it's about $40 or $50. The Gear VR is a little bit more. Gear VR is, if you get the brand new one, it's like $130, but typically within about 2 months, they drop it down to like $80 or something. But in any case, those are cool experiences. I would say pretty good VR experiences when you start thinking about what's really the cool factor of VR. When we think about it from game development stuff, if you're writing games for either the Oculus Rift or the HTC Vive, and you're taking advantage of these hand controls and you have the sensors and this thing called room scale where you can kind of move around the whole room, that's all fine and dandy for about a half hour. And then you start recognizing that, okay, this is almost like the Nintendo Wii problem, right? Where it was cool when it first came out. And it's neat that you can, Link in Legend of Zelda, you actually can swing. In fact, when you're playing games, you don't want to do that. You want to veg on the couch and push buttons is what you actually want to do. So I think that, playing some of these VR games can be quite exhausting when you're doing the standing up ones and things like that. So I think that people have, if you look at the trend in games being developed for VR, they've started moving towards seated experiences. Even though you have this capability of room scale and being able to actually physically move around your space, and that's all fine and good, but there's a big area in VR coming up with alternate ways of moving around in virtual space. Because no matter how big you get your space in your room, if you can get a 10 by 10 foot space that you can move around in, that's great, but that's still not going to let you walk across a parking lot or something like that. You still have to have a way of moving. So, there's a whole bunch of stuff in VR that talks about the various modes of transportation and how does it work. And so effectively it says, nothing says you can't do that in a mobile device. So what you've seen recently in these mobile VR devices is these little hand controls. Now, they track your hands-ish, let's say. When you're dealing with an Oculus Rift or an HTC Vive, it's accurate, right? You have these external sensors that are, seeing how your hands are moving and things like that, and it's accurate. Well, when you're dealing with a controller that has its own kind of accelerometer in it, and it pairs up with the headset, and it tracks-ish, right? So when you point at something, it's good enough for that. It has a little laser thing that kind of comes out of it in VR where you can kind of see what you're pointing at. So it makes life more convenient, where otherwise before that with the Gear VR, you have this little touchpad on the side of the thing where you would stare at something and then tap it, and then that's how you selected stuff. Okay, so now they're bringing the whole hand control thing into it a little bit, and maybe you could say it works okay for like shooters or something if you're going to do a point and shoot type game where it's effectively a pointer, so anything you can have a pointer for, it might work. But more and more what we're starting to see in virtual reality is that either the games are different or people are actually using that technology, VR, for things that actually aren't games. So games was kind of that initial thing that pulled people in, but now we're seeing it for like home entertainment and I think actually that's going to be the killer application for it, is things like home entertainment and sports watching and stuff like that. So if the example, I gave a presentation at our church about a month ago or something like that, about VR and AR and mixed reality and all this other stuff. And one of the big advantages of VR, I think one of the cool factors of VR might be, if you're a Packers fan, let's say, well, wouldn't it be cool to be able to sit at the end of the Packers bench or something like that at the game? Or if you want to take this to the extreme, wouldn't it be cool to effectively ride on Aaron Rodgers' helmet, have a perspective from Aaron Rodgers during the game? You can't pay for a ticket that's going to be like that, right? I mean, how many of you would be interested in at least experiencing that once if you're a football fan, or pick your favorite sport or pick your favorite type thing, having that kind of perspective? So it goes kind of two different ways. I used to have season tickets to the Bucks, and for my business, we had floor seats, and they were incredibly expensive to sit on the floor and watch a team lose. So, so it's it's the magic of the bucks. Games are relatively meaningless because what are you playing for? You're playing for like an extra 4 games at the end of the season because you're going to be the last seed if you make the playoffs and just get destroyed by Cleveland or something. And that's it. But in any case, they were incredibly expensive, and it was a cool perspective, right? But, you only got to see the action when it was at your end of the court or something like that. Well, in VR, they can place these, 3D cameras, 360-degree cameras around the arena and maybe have, 4 or 5, 6 different perspectives. So, and maybe even have the software that automatically switches between, under the hoop on either side, wherever the action is. So you're sitting here in VR and you can kind of switch your perspective and watch the game as if you're sitting there, but you're actually at home on your couch. I mean, that's kind of a cool concept. You can apply this to really any sport and have the best seat in the house, but they could sell that best seat 1,000 times. Now, then you have to think about the other side of the problem of what's going to happen to the stadiums because people aren't going to want to go to the game, or you're going to have maybe a different reason for going to the games. The games might become much more social events or something like that.
Well, I think it depends some on the sport because like Packers right now is a huge social event. Anyways, it's just the whole atmosphere that you cannot get that with VR. And that's not with every sport. Like the Bucks would be a totally different case.
No, right. And I think even beyond that, you have even fans of that appreciate different aspects of the sport. Yeah. So like take the Brewers, a big part of baseball is tailgating, right? But then you have a big group of people that just don't care about tailgating. Mm-hmm. They show up at the 2nd inning or something like that, so they don't have to deal with they leave in the 8th. That's the to avoid traffic and stuff. So you're going to have that population that they don't care about that aspect of it. But you're right. You're going to have the people still showing up to the stadiums for the party aspect. And what you'll also probably see is the price per ticket at the stadiums come down because now they're going to be pulling in revenue from external sources by selling the same great seat 1,000 times. There might be some sort of bandwidth limitation or something like that, what they can push, but something like that. So in any case, kind of pulling this back around, I mean, we can sit there for a day and imagine all these cool things for VR. But what was just announced by Oculus, and Oculus is actually owned by Facebook. So this is a kind of a cool push. Like I mentioned before, this idea of mobile VR kind of started off as a cool thing to try. Then it wasn't convenient. Then we went to the kind of the professional VR, which was really expensive, really cool once you have it set up, but expensive. And also doesn't travel with you. And if we're making this argument that VR is kind of focused on multimedia, like I spend a lot of time every day in VR, and at first it was kind of trying every application and stuff like that, all the different games, and now I pretty much just watch shows. I mean, if there's one killer app for VR, it's watch Netflix in a movie theater. That's it. You could be in a broom closet with the headset on and be as if you're at a movie theater watching your Netflix shows. That's done. It's worth it for just that. Well, one application. But, there is this prohibitive nature to getting quality mobile VR. You have to be on a very specific set of phones. Right. And the interesting thing, and I'm not sure why, is Apple hasn't jumped on that bandwagon. I can't imagine why they wouldn't have come out with Apple's $300 Apple mobile headset thing that works only with the iPhones. I mean, if you look at these mobile VR helmets, there's not a lot to them. I mean, they don't have all the internal mechanics because this is your computer. The phone. So, yeah, I'm not sure why they may have missed the boat on that. We'll see. Because what was just announced is this move away from the computer, the super expensive computer, and a move away from having to have the specific cell phone. So now with the 2 things they announced, one was called the Oculus Go, which I think is the thing that's most interesting to what we're talking about here, which effectively is the Gear VR, the thing I mentioned earlier that works with the Samsung phones. But only works if you have a Samsung phone. But the other downside is if I want to use the Gear VR, I got to take my phone out of its case, make sure the screen's all cleaned off, and then you put it into the thing and click it, and then it starts the Oculus software. So you put the helmet on, then you're good to go. But there's that 30-second prep time. We don't like the prep time. But in any case, you're going to still be dealing with just a percentage of the potential customers who have the right device that works with it. And even within that, different devices have different performances. So I've had a Gear VR for probably a year now, over a year. I just recently, as a lot of you know, I switched from iPhone to Galaxy Note 8, so I have a Samsung device now. But before this, we had picked up an old used Galaxy S6, kind of the lowest quality device that would work with Gear VR. That was the minimum requirements, and you basically could stay in there for 10 minutes or something before your phone got overheated. And then so how good is that experience, right? Well, now, I got the S8, and, it's a lot more battery efficient. It has its own self-cooling stuff, blah, blah, blah. I did have to get a different Gear VR because the plug-in for it isn't physically compatible. Very Apple-esque of them. Very, but, whatever. But now, I have never seen the overheating problem. And I've watched 2.5-hour movies or something like that in there, and so it's good. So in any case, what they announced is a standalone effect. They call it the Oculus Go, but it's effectively a standalone Gear VR where you don't need a phone. It comes with the phone, if you will. I assume it's going to be Wi-Fi only, at least for the $200 price point one that they've announced. So you'll have to be on a Wi-Fi thing or download stuff to an SD card. I'm assuming if you wanted to download movies, but in any case, you just put it on, and you don't have to put a phone in there or anything like that. And that might actually be beneficial because I won't have my text messages and stuff popping up. But at the same time, maybe you want to have those text messages popping up. Because if we talk about all these positives of VR, one of the negatives of VR is it's a lonely place. You basically disconnect yourself from reality. Right. If I'm sitting in my office with a VR headset on, I typically won't wear earphones. I'll just listen to it through the speaker or something. But when somebody knocks on the door, you're making a guess at who it is. They have some solutions to that where you can kind of use the pass-through camera on the VR thing, and basically you're looking at it through your camera on your phone, which is passing through and showing you what you see on the screen, so you can kind of get an idea. But it's weird and creepy and stuff like that. So and there's actually a whole area of kind of, I guess, research, if you want to call it research, is how do you get the attention of somebody who's currently in VR? How do you get a hold of them? The Vive has this thing called Knock Knock, where somebody can walk up and knock on the front of the thing, and it pauses whatever thing you're currently in, and it brings up a thing as somebody's trying to get your attention, and then switches to the camera mode, so you can kind of look up at them and stuff like that. So that's kind of convenient, but that's a very interesting way of saying hello to somebody, is walk up and knock on their face. But in any case, I think this is going to be a very interesting thing for pushing kind of consumer VR forward. Because right now, the thing that's probably holding it back from us being able to realize those things like the seats in the arenas and that kind of stuff is just the number of people who actually have a setup that can use that. Right, and at $200 all in, that's you drop $200, you have VR. That's palatable for a huge group of people that weren't going to spend $600 plus the price of a good computer and stuff like that, or who happen to not have the latest greatest phone from Google or the latest greatest phone from Samsung. So it opens up the door for a lot more people, and then we have to assume Oculus is coming out with theirs. You're probably going to have 2 or 3 other competitors doing something very similar, which is going to open it up to a lot of people. Now, what's interesting for us, kind of dragging it back towards this class, is the tools that you use to develop for those mobile VR things, same tool we're using here. So it's maybe the things you develop get driven by how the people are using that software. Maybe you start turning, what you're doing for video games now into more business applications or productivity applications or entertainment applications, whatever it is. We call the class, or we call the major game programming, but that's more of a marketing stunt, right? That's, how do you bring, the people in, you've noticed computer science is primarily a 20-something male major. That's what it happens to be. So what do 20-something males do? They play video games, as a large group. It's stereotypical, but there's also a significant amount of truth in that statement. So the point is that if we can meet them with, that's the buzzword that they're gonna bite on. So that's why we call it game program. But the reality is we're learning generalistic tools that are applicable in things way, way, way beyond video games. And what I'm telling you here is that I actually think that the big market, I think VR is going to be the cool thing for the immediate future. We're probably talking, I would say a minimum of a decade of, I think, VR coolness. And then what's the next step going to be? Get rid of the helmet and you plug in or something. And you go into VR, your body goes into VR mode and they're projecting the thing right onto your optic nerves. There's a whole lot of cool books that actually talk about that. There's this one book series that I read called The Game is Life. Very interesting book. I think there's currently 6 or 7 books in the series, and we're waiting for the next one. But, the premise is that, society is built around this thing called the game. And the game is a virtual reality type thing. And people between the age of, I think, 8 and 18, something like that, there's it's the young people thing. They go into the game. And what the game does is we are all players in the game right now. So the game isn't really a video game so much as it is living a lifetime, but it's a compressed lifetime. So when a player, a real world player, is controlling me. So I'm a player in the thing. They go through their lifetime. I go and get these degrees in computer science and learn all the stuff I'm going to learn in a lifetime. That translates into 6 weeks in their world for my entire lifetime. And you learn all the stuff you're going to learn in a lifetime. Then you come out and they have a score associated with how they did in that lifetime. And based on that score, there's leaderboards and stuff like that. They can then use those points to buy another life. Go back into the game and live another lifetime. So imagine if you could live 15, 20 lifetimes, how much knowledge you would accumulate, just by living through multiple lifetimes, right? So that's how these people became more productive humans, is by living multiple lifetimes in VR. But when they're in there, they don't know it. So I'm not aware that I'm actually the avatar of somebody else. I'm completely immersed and feel like, God, this is my normal life. So interesting stuff like that. So there's kind of 2 dynamics. You have the game, and people are trying to be the high scorer in the game. And then when you retire from the game at 18, if you make it all the way to your retirement age, those points translate into money. So that you then use to live the rest of your life or whatever. So the best players in the world are also the richest people in the world, that type of dynamic. And it gets really cool about, actually, is the world where the game exists, is that world actually a virtual world? So there's a couple layers there. So it's actually pretty interesting for sci-fi and things like that. But it's one of those things where if we had gone back many years, we would have said, oh, that's a very sci-fi. But today, it's at least in the realm of plausible-ish, right? We can't sit here and say, well, they're definitely not going to be able to just put our brain into VR mode. It seems like that's something they might be able to do, right? So maybe in our lifetime. And how many of you would sign up for that? Would go into VR mode, like physically? Like you go and lay on a table, they hook you into all the stuff, and you're out. Any of you? You wouldn't? Yeah, I would be first in line. I'm an early adopter by nature. Like if Apple or one of these companies came out with like something that just like it was an implant in your eye or even replaced one of your eyes so you didn't even have to carry your screen with you, I would probably do it.
Just hope it doesn't have a problem. Explode battery.
I'd be willing to take the risk. Then I get the new Terminator eye. I mean, if they're implanting stuff in your eyes, they probably have new eyes they can swap in, right? Go in for the eye upgrade. Haha, get it? Yeah. What would Apple call that? They can't call it the eye.
Just be the eye.
The eye optic. Yeah, it could just be the eye, right? So, interesting. But that would be a very interesting thing, though, to see what percentage, where do people stop? Where would a human being, what's the step they wouldn't take to have the next thing? I don't know where that point would be for me. I'm so ingrained in technology. Let's do it. And then you're like the only person walking around with this device. Nobody's making apps for it because only 7 people have it. They got this useless eye. What am I supposed to do with this? All right. So in any case, interesting stuff for us that we'll be able to apply this skill set to. All right. So let's take a look at where we left off here. So we took our enemy out of here. We have a dude coming here. And right now it's going to fly off the end. We want it to bounce back and forth between those two things. So now one thing I want to do here is so that these guys are rigid bodies, correct? Yeah, they're rigid bodies. Now, one thing I want to do to both of these guys, and I want to see if it'll make the difference. I'm going to go ahead and I'm going to freeze the position of these on X and Y. I want to know if that will fight against the physics of it or if we can still move the thing. I'm not sure what the answer is going to be because when we freeze the position in X and Y, we're effectively saying, don't go anywhere, right? I think we're going to actually remove the rigid body from it, but I just want to see what happens with this. Okay, so that did kind of what I wanted to do. So even though physics is acting here, I put constraints on this rigid body, freezing its position, which effectively says don't act like a rigid body. But the advantage of this is I can make it act like something that prevents it from going someplace else. So, I don't know what's this? This is firegrass, we decided. Is that what we called it? Firegrass. The firegrass bumps up against the sign, and the sign is rigid. It's a fixed thing there that's not going anywhere because we've constrained its position to be fixed. Now, we could probably increase the mass to the point where it wouldn't go anywhere anyways. Think about that in real life, that, if any of us pushed up against a car, right? Technically, cars are movable, right? But they weigh so much more than we do that we would have to push really, really hard to move a car. So chances are it's not going anywhere. All right, so if we increase the mass to that point relative to our mass, then physics would say it's not going to move. But in this case, technically, if you shove the car hard enough, it would move eventually. Well, by constraining the X and Y, well, really, we only needed to constrain the X, but we constrained both the X and the Y. We've made this guy immovable in 2D space. Okay? Well, so then we might ask the question, well, why make it a rigid body? Well, we made it a rigid body. That way physics does its thing, right? We can technically bump into it, and it does stop another rigid body physically. Okay, but now we want to react to that collision. All right, so we're going to write a script for our firegrass. I think we already have that, don't we? Set the PowerUp container? No. Okay, yeah, so we didn't write a script for Firegrass yet. So we want to teach Firegrass how to behave. All right, so let's look at our PowerUp container right now. Our PowerUp container, currently when we show the PowerUp, we enable the sprite renderer on our Firegrass. We change its position to be its destination position, right? So it's now above the thing. We play some audio. Then we say it's enabled, so that in fixed update, we continually set as long as the Firegrass is enabled, we set the velocity on this guy. Okay, now what we want to do is we probably want to move this logic out of here and instead move it into the Firegrass, where it says, look, the purpose of our PowerUp container was to make the Firegrass exist. Now I'm a Firegrass. What do I do? So the script for the Firegrass is probably going to be the guy that controls what he does. And this becomes kind of the decisions that we make as a game maker, who controls who. You know, and there really isn't necessarily a correct decision. And this is where we can sometimes take some, we can say wrong terms, but interesting turns when we're doing game development, because we can almost think of it like the puppeteer, right? Where, you know, you have this one game object that's kind of, everything's a chess piece and we're moving it around. And then you're kind of at the mercy of maybe sequential things that maybe happen inside of an update, or running out of things that happen inside of an update. Well, even if we pause that thought for a second and we go back and think about how is the game engine actually built, you know, there's another resource that we're up against. The more game objects we have in the world, and then, well, we can think of that's going to have one limiting factor, but really for us, it's the more scripts that we have in the world that are attached to game objects. You know, the more we're kind of dividing up time. You know, the cool thing we have in today's world is we have multi-core processors and things like that. So the hope is since our processors are so fast and we have multiples of them, that we can scale our games pretty big before we really start running into issues with having too many scripts where we're calling update on 100,000 game objects. Let's just pick something ridiculous, right? So we're calling update on 100,000 game objects, and each one of those updates is doing something, right? Doing some kind of logic. Well, now all of a sudden that's starting to eat in, because that's happening on a per frame basis. And if we're going to call average performance 60 frames a second, that means 60 times a second we're executing a function for, what did I say, 100,000 game objects? That's a lot of function calls every second. So now we got to consider, what are we doing in those function calls, and can the processor and the GPU keep up with whatever we're doing? We start seeing what the limitation might be. Now we have to wait for the next good graphics card to be able to do a little bit more, a little bit more, a little bit more. So what we've seen over the last really many years is in computer science is we've seen technologies that try to offload some performance aspects onto the GPU. So we have this technology called OpenCL. How many of you have heard of OpenCL before? So it's a technology that Apple kind of bought into early. It was not designed by Apple. It was an open source type project. And, you know, OpenCL, the concept of this was if you have a so what's the difference between a CPU and a GPU? GPUs are CPUs are general purpose. GPUs are domain specific. Mostly they're floating point machines. Okay, they do a lot of mathy floating point math stuff. And actually, kind of an interesting side note, what's the difference between, if we just think about the NVIDIA lineup, what's the difference between NVIDIA's consumer GPUs, like a 1070 or a 1080, versus, have you heard of Quadros before? So NVIDIA has the Quadro cards, which actually are kind of the same card as the 10, but they're a lot more expensive. What's the difference? They have kind of the same guts in them. Sometimes they'll have a little bit more memory or something like that, but obviously the Quadros must be better in some way, right? Usually the Quadro cards are put into like higher end workstations for people who are doing a lot of CAD drawings and things like that. So people look at it and say, okay, well, I can get this card for $700, or I can get, let's call it the equivalent power card for $2,000. If you can get the same card for $700 versus $2,000, what are you buying? $700 one, right? Who would buy that $2,000 one? And what's actually interesting is other people go on over there and say, well, the Quadro card, this guy right here that's supposed to be this kind of the same guts, is actually worse for gaming. Does anybody know what the actual difference is between the Quadro lines and the normal line, the professional line versus the consumer line? It actually comes down to level of accuracy for the decimal points on floating point math. So if we're a gamer, we care about speed more than to the fraction of a pixel accuracy, right? We're seeing things at 60 or 80 frames a second. If something is off by a fraction of a millimeter, if we want to put it to real life terms, that's not a problem for us, right? You know, that's okay. Because the side effect is we got it faster. We got that number more quickly. But if we're doing, high-end design where we're designing a building or something like that, we have two things that are coming together. Fractions of a millimeter might make a difference between something fitting and not fitting. Okay? So that's where those Quadro cards come in. They allow you to calculate sizes of things up to not infinity, but functionally infinity when it comes to how big of an atom is to what's too big versus a perfect fit or something like that. So it becomes kind of an interesting thing that is more of a piece of trivia information, that the more expensive card is actually worse for gaming but far better for CAD stuff. So they're actually purposed for different things. The punchline. But in any case, if we look at, so lately we've been talking about these, really what we're doing in here is really these old 8-bit games, right? Games that we would have seen on Nintendo. And we're going to look at the second half, we're going to look at a different genre of game. Actually, I think we're going to look at two different genres of games the second 8 weeks. But in any case, platformers have sort of kind of made a comeback. We have this movement these days of retro gaming. I'm not necessarily sure why. I think maybe it's because the modern folks maybe almost missed some of the really retro games. We're kind of getting past that, where you never saw that. Your first system was a Nintendo 64 or something like that. Wherever that timeline flowed. But in any case, we certainly, if we look at a game from the early 80s to a new game that comes out today, this is night and day, right? We have 3D versus 2D, the texture quality, the graphics, everything about it is more, right? Now, what's driven that? I mean, do you think we wanted more back in the 80s? Sure, we wanted as much as we could get back in the 80s. What were the limiting factors? Well, memory. We didn't have a lot of memory. Our processing power was far less than it is today. We were working within constraints. Now, are we working within constraints today? Sure, just bigger constraints. So now, kind of the focus that we look at in today's games is the only thing we actually have to process is what's currently on the screen. And maybe the stuff that's going to be on the screen next. Right, you don't want to have half of an explosion going off, and then all of a sudden you turn your head a little bit, and now you have to render this whole new explosion. So you might kind of go out to a field of view that we're not necessarily seeing. Maybe it's 3 monitors, a monitor on each side in terms of what we're actually projecting, and maybe one on top, so that we're actually doing the math for stuff that's happening over here. But realistically speaking, we're keeping it within kind of our point of view. For what we are going to actually put processing power on. We're not going to worry about the enemy that's halfway across the world over there that we're not getting to anytime soon. We're not going to throw processing power at him. So I mentioned this technology called OpenCL, and what OpenCL does is it identifies tasks that are going to the CPU that are tasks that could be completed by the GPU, the graphics card. And it offshoots those to the graphics card, taking some stress off of the CPU so that the CPU could do problems that only it can do. So that's kind of the idea. So you get, substantially increased performance. So even though there's plenty of general purpose things that we're sending to a CPU, I usually teach that CPUs are effectively collections of magic tricks. And if you do enough of these magic tricks in a row, you've actually accomplished a task. Well, some of these magic tricks are doing things beyond just math. Fine. That's a magic trick that a CPU knows how to do that a GPU really doesn't. Okay, it wasn't designed to do that. If you look at GPUs, a multi-core CPU might have 4 or 6 or 8 cores in it. A multi-core GPU might have 1,000 or 2,000 cores in it, because each of those cores is much smaller, because each of those cores has a much smaller set of magic tricks it knows how to do. Most of them are math stuff. So what OpenCL does is it attempts to filter, sort the tasks that are going to the CPU and says, you can be done by the GPU, you can be done by the GPU, and just throws them over there so they get processed. And you get quite a bit of performance, because we can imagine that even in general purpose computing, a lot of math is also happening, right? So as game programmers, or even programmers in general, so that's where that word gets blurred, what do we try to do? We try to develop towards the machine that we're currently working on, or really, depending on the length, how long a piece of, if we think about game design, sometimes games might take 4 or 5 years to write, even with a big team. Well, what's the, how fast are computers going to be in 4 years? Well, we have to consider the computer, we have to consider the GPU, we have to consider the resolution. We have several things that we're guessing at. Right. So if you're a gamer, one thing you run into is when the latest, greatest, aggressive video game comes out, a game that's kind of focused on graphics and things like that. Usually it'll only run with all the graphic settings turned all the way up on ultra or whatever on the latest, greatest, newest everything. Right. So you have to have the graphics card that came out next week in order to run it with everything turned on. And that means that game did a good job at guessing, because when they started working on that, they had to make some decisions that were based on what they think technology will look like in 5 years or in 4 years, whatever it is. Okay. So, what if they guess wrong? Well, they guess wrong in the right direction. They now they have a game that doesn't look as good as some of the other games that are coming out, but at least it performs well. They guess wrong in the other direction. We can say the wrong direction. They have a game that looks even better than your average game that's coming out right then. But this is where they've started adding in this tuning of graphics things. So most games today have like a slider where you can choose how good you want the stuff to be. What aspects of the game that are requiring extra horsepower do you want to remove in order to make this game run well on your machine? So that's where they've kind of bought themselves a little bit of wiggle room, where maybe when you first get the game, you can only run it at medium graphics. And then you get your new graphics card, now you can jump it to high or ultra or something like that. So anymore, they're making a guess towards a more aggressive guess, and then hoping that you at least meet the low minimum requirements. So they've given themselves a little more wiggle room. But in any case, regardless, we are working within limitations of the current technology that we're dealing with. So we're about to add a script to another game object. Now, in our world, we don't have 100,000 things running around, right? This isn't going to be a problem for us, but it is something that we want to at least consider when we're going to add another script, when we're effectively adding another update function that will automatically get called once per frame. We have to consider the ramifications of that. What are we going to do inside that update? How much performance? How many of our bucket of resources are we taking away for this particular guy? And then we have to think about it also in terms of prefabs. So recently we've been working with some prefabs where we built something once and that we want to use in multiple places, right? Well, if you're going to write something once and then you're going to use it in multiple places, that script is going to get called multiple times for each of those guys. So now you can imagine how you go from having 3 or 4 things in your world to having 30 or 40 things pretty quickly, right? When you start using your prefabs and you actually design your level. Right now, our level really consists of a single screen, right? When, we can imagine what we're going to do is when we build a Mario-esque level, it's going to be maybe 40 or 50 of these screens sitting next to each other, something like that, right? Or at the very least, more than one. All right. So we're going to build a new script, and we're going to attach it to our Firegrass. And this script is going to be in charge of controlling what Firegrass does. So I'll create a C# script. Call this guy Firegrass. And I'm going to go ahead and we're going to attach this to our Firegrass for right now. All right, so we have that script attached to our Firegrass. Oh, I want to open the script. Okay, so we have that script open. Now we got to decide, how do we want Firegrass to behave? Well, we have to keep in mind that the Firegrass script is going to be on when this guy first launches. So we kind of come back here and we click on our Firegrass. And we have this script called Firegrass. Now notice that I can actually turn that guy off. Because really, I don't want the logic associated with my Firegrass script to start until after he's been repositioned. That makes sense? So I have this Firegrass object, but he's kind of a dummy, right? And only once I turn him on, I click his brain on, do I want him to actually start doing stuff. Now we can handle that a couple of different ways. We can either have the script disabled and then enable the script when we're ready for him to start trucking. Or we can throw a Boolean in there or something like that where the script is basically just skipping update over and over and over again until it finally says you're good to go. That makes sense? So let's mess with the turning the script on and off thing for us, because that's probably not a direction that we went with our homework, right? We probably do like more of a Boolean flag, make your Firegrass not run away until it's time to run away. Okay, so we'll go a little bit different direction to introduce some new stuff here. Okay, so by default, I'm going to have this Firegrass script disabled on here. Now I'm going to, and I need to look up real quick in the documentation, Unity component enable script. I need to find the object container that holds our scripts. Script.enabled. Okay, it looks like we could do it just based on the name. Okay, I think I got how this will work. I'm gonna have to try it a couple times, but pretty sure I get the gist. So this guy is actually going to be called Fire Space Grass. So we have to look at how this component is named here. So I believe we're going to have to call it that way, even though I have named it Firegrass here. So we'll see, but we want to access this component that's of type script called Firegrass. So for right now, what I'm going to do is just to kind of get the ball rolling here, so to speak. We're going to go in here and I'm going to steal our code for our PowerUp container. Because right now inside a fixed update, we have our Firegrass rigid body set at 7. So I'm actually going to steal that code. So we're not even going to have a fixed update in here. Because what we're going to do instead is when we show that power up, after we've positioned it, I'm going to go ahead and turn the script on for the Firegrass and let him take over. All right, so in our Firegrass, I'll go ahead and we'll put a fixed update in here. All right, and this guy will just set the velocity. It's actually not going to be this dot Firegrass. It's just going to be this. And I'm going to go ahead and I'm going to give him his rigid body so we don't have to look it up every single time. So we'll create a private rigid body 2D. Call that guy RB. And then inside start, we'll say this dot RB is equal to this dot get component rigid body 2D. All right, so now we have access to that rigid body. So then down here, we can just say this dot RB dot velocity is equal to vector 270. And what I'll probably do is I'll do the same thing for this vector 2. That way we're not creating new memory every single time. So we'll have a private vector 2, we'll just call this guy speed. We'll say this dot speed is equal to a new vector 2. And then each time in fixed update, we'll set the rigid body's velocity equal to this dot speed. That way we're only creating the new memory one time. We probably wouldn't have noticed a difference in actual performance at this size game, but these are little things we can do to help us stay within our resource constraints. Okay, so when this guy turns on, whenever the script is active, our hope is he's inactive at the beginning and then he becomes active. Whenever this script is active, he's going to every 60 times a second, he's going to reset his velocity to speed 7. Okay, that's what he's going to do right now. Now inside of PowerUp Container, when we show a PowerUp, the last thing I'm going to do is I'm going to turn that script on for our Firegrass. So I'll say this dot Firegrass dot get component, and our component was called. I just want to see if we. Okay, I think we need to give it the string name. And this guy is going to come in as that guy's a class. Okay. Well, let's see if it will match up against the class name. .enabled is equal to true. So we're attempting to turn the script on. I don't know if this is going to work or not, but we will find out. And then once it's on, we expect this guy then to take over and make our firegrass move. All right. So our hope is when we run this right now that it does the same thing that it did earlier, right? But it's the means to an end is a little different. All right. Now, just to make sure that it actually did what we wanted it to do, I'm going to choose not to enable the script, which means it should not move in this case, right? Because by default, our firegrass script is off, and we want it, in this case, it's going to actually remain off. Yeah. All right. So now it's not going anywhere because we have it turned off. So that's a way we can turn on and off abilities. Now, we would probably say, depending on how this is working under the hood, this is actually the better way of doing it, right? As opposed to throwing a Boolean in here and having it check that Boolean on fixed update or worse update, or probably worse update. And then only firing when that Boolean was true. We would set that guy's, that game objects, we'd send him a message to set the Boolean equal to true. That means you can go. And then when it's true, he would actually execute the stuff in there. So presumably this is going to be higher performance, but at the very least we're putting the onus onto the game engine. All right. So now our firegrass is going to start going. And we have him moving at a speed of whatever. Now, what we want him to do is, just real quick, I'm going to just want to make sure this does what I think it's going to do. I'm going to multiply that speed by -1. I want him to go in the opposite direction. Just want to make sure it does that. Okay, it does not. It's a 0 thing. Okay.
Mine went in the opposite direction.
Yours went in the opposite direction?
Yeah, it did.
Velocity, speed. Oh, I still have my script off. I was testing you and you failed. Okay, there we go. So now we know we can go in the opposite direction based on flipping inverting the speed, right? Okay, so now what we want to do is when we're going to call these guys, I know right now we put them in, we just have, do we call them anything? I'm going to rename these guys just bumpers. Call that guy bumper 2. This guy will be bumper 1. Okay, and we're going to go ahead and use tags to let these guys uniquely identify themselves so that the firegrass knows what kind of thing did it bump into, because it's going to be hitting a bunch of stuff, right? It's interacting with the ground and things like that. We don't want it to do stuff under those circumstances. So we're going to go ahead and for our 2 bumpers, we're actually going to go ahead and have to give ourselves a new tag first. So let's call this we already have a tag called bumper, but we have other kinds of bumpers, right? That might be okay for us to have other kinds of bumpers, because generally speaking, if we're building a game, we're going to kind of have things that that should act like bumpers. The issue is I think our current bumper is being used to give ourselves a path for our enemies to bounce back and forth between. And as we have it set right now, that could be an invisible path, right? So whether that's correct or not, that's the decision we've made in our game. And now that's the world we're living within. So I'm going to go ahead. I'm going to create a new tag. And let's just call this guy a PowerUp yeah, we'll call it a PowerUp bumper. This also might be making a poor decision. We might decide that we're going to have any structure in the game. So if we think about Mario that has all these pipes and stuff like that, these are, solid, maybe we can call them solid objects. Because we imagine that we're going to have things in our game that are going to be just solid objects. That's what they are, right? So we can say something like this is a solid object. So whenever it hits a solid object, it should reverse in direction. So we would just decide that things that we put into the game that we want to be solid are solid. Okay, so now with that in mind, I'll select my two bumpers here. We'll make both of these guys solid objects. All right, now in our script, I'm going to have another variable. So this is in our Firegrass script. And the variable is going to be private int multiplier. And I'm going to start that guy off at 1. And then we're always going to multiply our speed by this dot multiplier. So this will keep them going in one direction to begin with. And then we'll just keep flipping it. We didn't actually have to do it this way. We could literally invert the speed, but this multiplier might help us in the future to tell us what direction we're currently going. Might be a more convenient way of telling us what direction we're currently going. Again, these are decisions that lead to potential performance implications as the game gets bigger and bigger and bigger. So we can kind of recognize that we might be playing with fire a little bit here, but we'll just roll with it. All right, so we're going to multiply it by a multiplier. Now, we're going to have, on collision enter 2D. So when we hit something, we want to know if the dude we hit was a solid object. So we're going to say if collision dot tag dot game object dot tag is equal to solid object. So if I bumped into a solid object, what am I going to do in response to that? I'm going to say this dot multiplier times equals -1. So I'll flip my multiplier to be the negative of what it currently is. All right, and that should hopefully then make it go in the opposite direction until it hits the next one and then goes in the opposite direction and so on and so forth. Our baby's like an ice skater. Very exciting. Oh, no! No! I have not died. I downloaded an emulator on my my phone the other day and was trying to play Super Mario Brothers. I'm terrible at it. It's not like riding a bike. I say riding a bike, you just get back on, you're fine, right? It's not like that. I mean, I was just terrible. I was able to beat the first level, but I basically had to just skip everything. I just jumped and just I was able to get to the end. So I had no coins, just nothing. So I'm pretty sure I've hit the limit of my ability. I mean, the problem is that I think on the emulator, the buttons are really sensitive because it's just on the touchscreen. And I'm developing in my other hand now, but I have tremors in my left hand. So I'm constantly tapping the button, even though I don't mean to tap the button. Just stupid. You just get old. I mean, they say it's benign, so they don't think it's Parkinson's or anything. I'm just flopping all over the place, but whatever. I guess it's just a thing. So my video game professional days are behind me, I guess. See, where it'll really get upsetting is when it starts affecting my golf. It's actually interesting. You would think that would affect putting, but it really has not affected my golf. Must be just when I'm holding it that way, because it affects me the most. If I just have my hand out, it doesn't shake that much. But when I have something with weight on it and I start so eating is the funniest. If I'm trying to control a fork, as I get closer, just flopping stuff around. So who knows? At least I have a good sense of humor about it. At some point, I'll just start throwing stuff on people I don't like and blame it on the tremors. All right, so this guy seems to be doing his thing, going back and forth or whatever. So now we probably, well, in this case, we don't want the PowerUp to kill the baby, right? It's like a trap. We want the baby to interact with the PowerUp, and something happens. So in Mario, what happens when under the mushroom, the normal one, Mario gets bigger. Right? So Mario is going to get bigger. So how do we modify the size of our dude? Now, we have a couple of options here, right? We can actually have two different babies. We can have normal baby and we can have super baby, and then swap the two. Or we can actually scale the baby. So if we think about this, our player right now, he's scaled 10 by 10. If we make him 20 by 20, he's not going to fit under stuff at that point. So maybe 15 by 15. Let's see if he fits under stuff at that height. Okay, now he fits easily. Just to make sure all my stuff moved. Oh. Growling, we need to give him a little more oomph on his jumps. So let's go into our player script. Do we have a variable for we probably want to give ourselves a variable for our jump strength. So let's call this private float jump power. Do we? Where's it at?
We have a public one. At the top of anything.
Oh, thank you. Well, good, even better. We made a great design choice. So we'll come to our player. And we'll go to his script. And here's his jump power. Right now it's 1400. Let's change that to maybe 1800. Give him a little bit more oomph. Oh, almost. 2000. Okay, so now I'm going to scale the baby back down to 10. And I want to see, because we have the baby set as auto mass, right? Yeah, I want to see with that scale if now his jump power is too strong. Yeah. So the auto mass is causing his mass to actually physically change. So I'm thinking here that what we want to do is we want to turn auto mass off. We'll give him a mass of 3. Okay, so then let's pop this back down. What was it, 1400? Make sure he can still hit what he needs to hit. Okay, probably needs to have a little bit more power because he needs to be able to jump up there, right? So we can sort of hack up there, I guess. Just set it to 2000, which we saw before. Seemed okay for the. That seems too. 1800. All right, I think that's pretty decent. So at 1800, he's okay there. Let's switch him to 15 by 15. Yeah, looks like he's hitting the same jump heights now. Ooh, that was a little sketch. Yeah, usually we want, if you saw what happened there, Baby triggered the, I was able to trigger the power up. There we go. From the top. Probably don't want that to happen. So we're going to go ahead and how would you remedy that? Okay, so we're going to shrink down the box collider, because I think if you remember from last time, we made the box collider kind of stick out from the bottom a little bit. Now let's just make it squeeze down so it's not quite as tall. So we're going to take our PowerUp container, which has a box collider on it. We're going to edit that collider. And notice how we make it come out the bottom here a little bit. I'm just going to grab the top here. And we'll just, no, because that's going to shrink the whole thing. So I'm going to undo what I just did. And now what I'm going to do is we'll change it directly. I can't move just that one piece. Okay, so this will at least allow us to do all right, so I made it 0.7 for, so it's clearly below the thing there. And then I'm going to make it shorter. So let's do 0.6. Oh, 0.06. 0.4. That actually might be okay. Let's try that out. So we just put a little bumper there on the bottom. All right, so that felt okay on that side, and now we shouldn't be able to do it on top. All right, we'll call that a little hack. What happened there? Got like stuck. He's moving. He's just. Yeah. Well, I guess regardless, we can mess with that a little bit next time. Is that this? Maybe that's that thing there, but we'll mess with that next time. That's not that big of a deal. So what we want to do for Tuesday bring your game up to speed with this. I would go ahead and update yours to deal with the script enabled versus disabled. But what we want to do is when we collect the power-up, so when the power-up collides with us, we want to consume the power-up, whatever that means to you, and then we want to increase the scale of your player. Okay, and you're going to do that through the transform. Make sense? All right, so you can look at the documentation for it, but it's not dissimilar to some of the other things we're going to do. We're going to change his scale is a vector. Well, you can make it a vector 2. Right now, his scale is a vector 2 that's 10 by 10. I would make it a vector 2 that's 15 by 15. Get where I'm going with this? All right. I will see everybody on Tuesday. Don't forget about the CS get together at 11:30.
The class on Tuesday is regular, no midterm or anything.
No, I usually do my because that's week 7. It's next week, right? Yeah, I'm pretty sure. No. Well, so the answer is yes. It's a normal class. So I usually do my midterms like right after break, but I'll probably do it like the Thursday after, not the Tuesday. So we'll talk about it on Tuesday. Ask again on Tuesday about it. I haven't even thought about midterms.
Because Grace and I were like, none of our professors have told us anything about midterms. And we're like, they're just going to
I always announce my exams at least a week in advance.
Okay.
So you'll always have a week.